Welcome to the Technical Interview, a podcast dedicated to exploring various technical topics for your interview needs. Have you ever wondered what are containers, Docker, or what is Kubernetes? Well, this episode is for you. Let's start with containers. Think of containers as lightweight, self-contained packages of software that include everything you need to run it. The runtime, the code, the libraries, the environmental variables, everything is contained within it. The cool thing about containers is the fact that they are isolated from each other and the host. So you can run them next to each other. Even more cooler is the fact that these containers are self-contained. So they could be moved across any environment easily and without any problems. This solves the problem that, hey, this code doesn't work on my machine, because you can easily move it from the developer's laptop to a workstation, to the cloud, to someone else's computer, and the code would act and work the same across all of these environments. Let's describe containers using examples in real world. Imagine you're moving houses and you pack everything you need into boxes. Each box has everything you packed, so when you open it at your new house, you can use the contents right away because everything is already inside of it. You might be wondering, what are the benefits of using containers? Well, here's a few. Consistency. Given that everything is contained inside the container, it provides a uniform environment to reduce discrepancies between development and production. Another core benefit is efficiency. Because they share the host, containers are more resource efficient than traditional virtual machines. Another one is isolation. Containers offer secure application running environments, as one container process and files are isolated from each other, and containers cannot access each other's files or data. Now that we have learned about containers, let's talk about Docker. Docker is a platform that simplifies the process of building, shipping, and running containers. It allows developers to package an application and all of its dependencies into containers with simple and easy-to-use commands. Docker provides an ecosystem and workflow for managing the life cycle of the container, from development to deployment. Moreover, Docker makes sure that the container can be opened and run anywhere without any issues. Now, let's describe Docker using real-world examples. Docker is like the best packing service out there that you can hire. It takes your application and all of its dependencies and neatly packs it into containers. Let's talk about the different components that make up the Docker. The Docker file, it's a file that contains the commands for building an image. The Docker image. The Docker image is a template from which the containers are made. And the Docker containers. There are instances of the Docker images that can run using the Docker engine. So let's look at the real world example. Think of the Docker file as instructions to create a blueprint, and the Docker image as a blueprint created based on those instructions. And at the end, think of the Docker container as the house that will be created based on those blueprints. Lastly, let's talk about Kubernetes. Kubernetes is an open source platform designed to automate the deployment, scaling, and operations of containerized applications. It groups containers that make up the application into logical units for easy management. So what does that mean? It means that it is an easy-to-use software to manage your containers. One word that keeps coming up when talking about Kubernetes is pods. So what are pods? Pods are the smallest deployable unit created and managed by Kubernetes. A pod represents a single instance of a running process in your cluster. Pods contain one or more containers. So why should you use Kubernetes? Well, there are a few reasons. One is load balancing. Kubernetes can automatically load balance for you. Second one, it's self-healing. In other words, if the container fails and the code stops working, it will start a new one and keeps going. Another one is automated rollouts and rollback. You can manage your applications and automatically roll them out, deploy them, and afterwards, you can roll them back if something goes wrong. Well, I hope you enjoyed listening and learning about containers, Docker, and Kubernetes. Thanks for listening, and hope you will come back to learn more about different technical topics. Till the next time.